Right, so a common flaw in aquaponic systems that we design around, right, don't affect this system is got to do with tank size. What happens is, one, when you harvesting these fish, in most other systems you got empty out your tank and waste all of that water to get access to the fish. Now, in this system, you simply put a pump onto the output and pump all the water in this tank out and into the other tanks. So the 2 feet that you got in this tank, because all the tanks is the same size, there's 12 tanks, so 2 inches of water will going. The water level in each tank will rise 2 inches if you empty out this tank into the main system. And once you got the water at 6 or so inches, harvesting the fish in the tank does be extremely easy, because it's only a 5-foot diameter tank. So you could go in there with one net and scoop out whatever fish you want. That's one. And two, no, this one is the real killer. The thing with aquaponic systems, because the infrastructure cost is so high in comparison to other types of agriculture, what you find is that you need to do a pilot project before you actually get into a large-scale production model. Now, what's happened is that when you start in your pilot scale model, you use tanks, small tanks like these here. So when you got a small tank like this here, you get a certain water flow qualities and dynamics with a small tank like this. Like for instance, this water flow that coming in here is enough to circulate the water that the tank will be self-cleaning. Now, if you go from this size tank in a prototype model and you want to go to a full commercial scale model and you size up your tank, you're going to go from maybe a 5-foot diameter like this into a 20-foot diameter tank, which is a big tank that will tackle like all that area. But what happened is now the water flow model changed, because you extend horizontally from the smaller system to the bigger system. You extend horizontally, but you don't extend vertically. You still got the 3 or 4 feet of water. So what's happened though is that the flow dynamics of the tank can be different. So whereas these tanks here are self-cleaning, so the filter will work a lot more efficiently. In a big tank like that, you gotta move the water differently, and you gotta apply a lot more physical labor into the actual cleaning of the tank. So what's happened is the cost is vary a lot in going from a small scale prototype into a commercial type system. So to defeat that, what we do is to keep the small size tank but get a lot of them. So what can happen though when it comes to fish stocking density and basic fish handling and maintenance, because you got a manageable size of fish, the application of labor for one person is a lot more effective. So if you got a big 20 or 30-foot tank, you got to pump out all that water and then take 3 or 4 men, maybe a day or a half day to harvest. Whereas this tank, I alone could pump out the water and harvest it in 15 minutes. So you got a better handling of the fish that way. And also with the stocking density, the total stocking density, I could keep enough 2-inch fish in one of these tanks to fill up all the rest of the tanks, right? When them at harvest size. So what's happening is that I could keep the fish at the correct stocking density all the time. If you got a big 20-foot diameter tank, you can't stock that with big fish one time. You gotta put in little fish in there, so then you got a lot of small fish in a big set of water for the majority of the life, right? So you can't stock the fish as effectively as in this one, where you got 300 gallons of water and you got the correct stocking density for the size of fish that you got. And also when it comes to the breeding of the fish, because tilapia does breed so easy, a high stocking density does allow or create such a situation where all of the little fish will be eaten by the bigger fish because they simply have no place to hide. And how we use that to our advantage is that we do a cage, a breeding cage. Here we got 4 or 5 breeders in there, and after each batch we just move the breeders, the cage, just take out the cage, put it in the next tank next door. All right, so right now they're just going to breeders in the cage. Then when they release the young ones out the mouth, we'll take out that cage and put it in another tank. So that's how we do. So this tank will be the last tank that get harvested. Then you just put in the cage to restart that again, and it continue like that all the time. But also when you harvesting the fish, say you harvest this tank, all the fish is not going to be at the same size. Some may be females because we don't use the hormones or anything like that. So some may be females, some may be males. And what will get happening is that the females can take probably a month longer to reach harvest size. So what we're doing is we take the females that in to harvest size and put in the tank that's going to harvest in the next month. So then be ready for next month to go with the next batch and be at the correct size. Now, the thing about a community tank, or with all of these tanks again, is that you could grow different species of fish. So you got some Oscars in this tank that love insects. Oscars love insects. So like in a case like this, when I got caterpillars eating my Chinese cabbage, as always, I could just come, throw this in here. The Oscars will eat the insects, the pacos will eat the Chinese cabbage. So that way I didn't lose too much nutrients from the system. And the pacos eat a lot, and the Oscars eat a lot. So that's supplemental feed for the system as well. So basically, yeah, the stocking density and amount does play a very important role in aquaponic food production, and that's how we utilize it for the owner operator type system.